Hello and welcome back to a new video here on the Ludwig Fusel channel. Again, in D3D12Ez, we're gonna continue on our journey through DirectX 12 and a bit more modern approach, a bit more just encode approach with less explaining, less PowerPoint and more hands-on. Alright, so what have we done last video? Well, last video we made sure to get the buffers from our swap chain because, well, the swap chain infrastructure code that manages DirectX 12 buffers takes just 2D, so a two-dimensional image, which we later on want to draw to, and the swap chain is managing them to put them on the screen, but we need them for drawing, and we get them for drawing now by calling get buffers and release buffers that we implemented on our own to make sure to always have a valid comp pointer to our buffers, and we can resize it, and all of our old functionality is still in there. Now in today's video I want to talk about resource states. Now well, resource states are certain, kind of like states a resource is in, as the name suggests. However, it is a bit of a complicated concept, and many people think, hey, why do I need it? Well, if a resource, as I told you last video, is just a pointer on the GPU, basically, with some data associated to it, and maybe some padding and alignment and stuff, but yeah, kind of like the point at the end of the day, it is a resource, a pointer, a memory region on the GPU. Why does such a memory region has a resource state? Well, it has a resource state because the GPU is a processor than every other processor as well, which means that it has memory management units, it has virtual addressing, and it's basically its own system on a chip, with a bit of RAM outside of the system on a chip. But in general, the GPU is similar to a CPU, its own processor, with own RAM, with own everything. Like the GPU in general, it's a processor, right? It is a specialized processor, but it is a processor. Difference between the CPU, the GPU can't run without it. The GPU always needs the CPU that feeds data to it so that it actually can do something. But in general, it is a processor than everything else. Now, since it is a processor, as I already told you, it has memory management, and it also has virtual addresses and addressing and memory protection, everything on it. This is good, because that's what you want. You don't want to have a corrupted program overwriting data from some program else. Maybe some confidential data or operating system stuff. You don't want to have a game screwing with your operating system, right? That's not what you want to have. That's why we have memory management in the first place. Now, since we have memory management, we have a big issue. The problem with memory management is that it is timely costing. And if it costs time, it's bad, right? Because on a GPU, we want to make things fast. We want to write fast to buffers. We want to read fast from buffers. We want to have everything as fast as possible because we might need to do very, very complicated calculations on a per pixel base. We already need to do so many optimizations on the game engine to make it run on the GPU, on current GPUs that are already highly optimized. If we do like the idiot approach and the kind of like straightforward approach in the game engine, we're not going to get the pixel throughput that we need to run a game. And we really need to optimize it. And that's the big problem in graphics. You need to optimize. And that's also why we need resource status and why memory management on its own doesn't work. The thing is, memory management is slow, memory management units, and we need to have options to optimize the access to the memory. And I can't tell you how it's implemented on the GPU because I'm not working at a GPU vendor, and you're not going to get access to these knowledge, how it works there. Or not as easily as straightforward as you would think. However, if you have resource states, it's going to make the story a lot different and faster, because if I have a resource state, I can actually tell the GPU how that block of memory is used. So if I tell the GPU, hey, this memory is going to be used as a texture that I want to read from, then the GPU can optimize it. So it's going to actually put it somewhere on the memory and tell it, all right, memory management unit, don't move that block around. Just keep it in this physical address and don't move it around. Then I basically know, all right, it's going to be used as reading for it, and then I can put the data already in a cache. So for that virtual address, I can put the physical address in the cache, lock it in, and say, all right, as long as it is in that state, it's going to be resident on maybe that cache or that lookup table, and while it's on there, it is going to be easily accessible by the cores. Would be one thing that you could do. That's an optimization that you can apply. Does the GPU vendors apply these optimizations? I don't know. This is something I would come up with if I would build a GPU. However, to do these kind of optimizations on a driver level, on a hardware level, on like any level in the whole chain, to do optimizations, you need to have meta information on how a resource is used. And that's exactly why we have resource states in DirectX 12, so that we can give the GPU hints how that resource is used. We can give the operating system hints how the resources are used, the DirectX 12 runtime, like everything that's in the chain. If we just have a resource, just a pointer, it doesn't know what to do with it. If we give it a state and the type of resource, it can internally optimize it, put it in the right direction, optimize access to it, put it in the right memory location so it's accessible, and do a lot of stuff with it. And that's why we have resource states and resource types. Now, resource type on the swap chain is really easy. It's a texture to D, it's a buffer, texture to D, yeah. A type of resource. Now, the resource state is a bit different because resource states actually change. It's not static. Like if we have a buffer, it's always a texture to D. However, these resource states are actually changing. For example, in case of our back buffers, we kind of like have two resource states imaginable. We have run resource state, kind of like the state used for drawing, called render target, where we basically tell the GPU we want to access it, we want to render to it using something called the output merger, but we're going to get to it. So we have a resource state, render target. On the other hand, we have the state where we want to present it. So we kind of like want to read that memory area and send it per scan lines to the monitor. So basically line by line over the HDMI, DVI, DisplayPort cable. And because we have the state as well. So we have two states, and these two states are changing. These two stages are, these two states are changing a hell of a lot of times. So if we have like two buffers and 60 FPS, the resource state per buffer is going to change 16 times a second. Because we have two changes per frame, and every buffer comes every 2 frames, makes again like two changes per frame, or in general like per buffer as well. Now, what we actually need to do is we need to manage all of these states manually. So the swap chain is not automatically managing these states if I call like present. Why is it not doing that? Well, because it doesn't know how we use our buffers. For example, it could be that we first do a hell of a lot of infrastructure rendering to other render targets, then we take our buffer, render to it, and then we want to present it. Or we might want to already finished rendering to our buffer, and then we are doing some other work before we're going to present it on maybe a different buffer or some intermediate resources. Like the XGI doesn't really know how the calling pattern or the usage pattern of the GPU from our application is. So it can't do the state management for the buffers here. So actually what we need to do is we need to do all of that state management on our own. Before we draw to the back buffer, to the D3D12 resource that we just obtained, before we draw to that, we need to make sure that we put it in the right state. We need to put it in the state back render target so that we can render to it. When we are done with it, we need to put it in the state back buffer so that we can put it on the screen. And that's what we want to do today. We want to change these resource states. Now, how do we do that? Well, all resource changes are done through something called memory barriers. Yeah. And that's what we want to basically do. Memory barrier, where we're basically going to tell that we have a transition of a resource state from that state to that state. And this is done using comment lists. So we already talked about that, comment queues, comment lists for scheduling work. And now we are actually doing work on a GPU, and the work is to change the state of these resources. It is done via comment lists, via resource barriers of the type transition, state transitions, resource barriers, memory barriers, resource barriers on a comment list. So what we need to do is we kind of like need to have two functions that allow us to put it in the right state. So what we're going to have is a void begin frame that's going to be called when the frame is going to be started, and end frame. Begin frame and end frame. These are the two functions. Begin frame is going to make sure that we can draw on that resource, and that the resource later on is also going to be set and activated on that comment list. And we have an end frame function. The end frame function is going to make sure that we are on the right state for presenting, so that we then can call present. Now, of course, we need the comment list. So D3D12 graphic comment list, whatever, 7, is that a thing? Oh, no, again, press Control A. 7, 9, 8, 7. Yeah, 7. Yeah, let's call it CMD list here. So begin frame, end frame, comment list. Okay. So now let's dive into these functions, and let's see how we can do a so-called memory barrier resource transition. So CMD list has a function barrier. resource barrier. There it is. So it has a function called resource barrier where we can provide it a barrier count and a barrier pointer. So actually what we can do is with one API call, we can introduce multiple barriers, and that's also what you should do. This DirectX is going to complain if you call resource barrier multiple times with count 1. It's going to say, hey, group these calls together because API calls are slow. We want to have fast APIs, so normally you're going to write some infrastructure around that. We're probably going to do it at some point. However, for now, we're just going to do a plain old one single resource barrier to change the resource into the correct state. Now let's take a look at the struct D3D12 resource barrier bar for barrier bar. There it is. Let's put it in here. All good, all done. Now, how does this resource barrier look like? Let's peek into it. Let's take a look at this. All right, so you can see that a resource barrier has a type, flags, and a union of types, or not types, but basically kinds of resource barriers that might be applied. So you can see that we can have transition, aliasing, and UAV, unordered access view. Resource transition in a special way. So what we first want to do is we want to specify the type, right? So we want to say that we're going to have a normal resource transition. So type is D3D12 barrier type transition. This basically means, all right, that's the kind of union value that I'm going to use and how I'm going to interpret that result. What we then also want to do is we want to define flags. And you can say something like begin only, end only, and none. This is something called, are they called floating barriers, transitioning barriers? I think they're called floating barriers. Basically what you can do is you can mark an end and you can mark a begin, and the GPU is then gonna decide the right time between begin and end to do the barrier, or at least do it at end, even through end. At the time end is coming, it might cost more. So in general, what you would do if you would want to do it the right way, is you would actually, as soon as kind of like present has been called and the other frame is there, you would already tell it that at some point the transition is going to be done, and at some point you're going to see now it's enforced. However, we're going to keep it simple. We put it to none. These kind of like floating barriers, not quite sure how they are called, are a very advanced thing that you're probably not going to use. All right, so now the next thing that we need to do is we need to describe this subtype transition. How does this transition look like? Well, I can actually peek inside of that as well and take a look how a resource transition works. Now, a resource transition works by specifying 4 parameters, a pointer to the actual resource that we want to change, a sub-resource. So actually, a resource itself can have multiple sub-resources, but that's also something a bit more advanced. In our case, we're not going to have it, so we're going to put it to 0. And then we need 2 states, the state that it is currently in, so the before state, and the after state, so the state where we want to put it to. So the resource we want to change, not minding the sub-resource, the current state, and the new state. That is basically what we want to do here. So how do we do it? Well, we're going to specify the resource itself, which is going to be some of these buffers. For example, the buffer 0. We need to figure that value out, so I'm just going to put a dot in here for now. Then we're going to specify the sub-resource, which I'm just going to 0 to 0. And then we need to specify the state before and the state after. Come on, after. There you go. Now, which resource states are available? Well, you can see that there are many. Resource state, all, shader resource, comment, copy destination, copy source, depth read, depth write, generic read, index buffer, indirect argument, non-pixel shader resource. And these are all the start ones, but I also want to have the other ones. The 3D12 resource state. Here, video process write, video process read, encode video, decode video, vertex and constant buffer, stream out, shading rate, so many things. However, what we want to specify is the render target. That's the resource state that it shall have afterwards. We want to render to it. And before of that, we can actually see what it might be. I think it's actually in the comment state or the generic read state. However, there is a state that's also called present. I don't know if they differ. We could see if they differ. Let's see. Present is 0. and common state is also 0. So the state common is kind of like the state for presenting the resource. However, we want to call it kind of like use present here to make it a bit more visual what we are doing. We are from presenting that frame to drawing to that frame buffer. That's kind of like the thing that we do. We could just specify common. However, present makes a bit more sense because it kind of like it looks like, right? We are presenting it. Currently, it's currently used for showing on a monitor, on the window, and now we want to render to it, and then we're going to place it. So here, you can see, we want to make a resource transition, not a special thing, just a very plain basic one. The resource is going to be one of our buffers, and the state before was the state where it got presented to the user to see it, and afterward shall be now the render target, so we can render to it. Now, let's replace the dot. How do we want to replace the dot? Well, we actually need to keep track which buffer is currently used for rendering. We could do this on our own. Every time we call present, we could kind of like count up a number, like kind of like current buffer index equals current buffer index plus 1 modulo frame count. We could do this on our own. However, then we need to handle like these special things like resizing it when the buffer get recreated. Actually, the buffer index goes back to 0, and it's not really clean, and you kind of like have a bit of arithmetic that's not good. What I would recommend is every time you kind of like call present, you want to actually then store the current index of the buffer. So what I want to do is kind of like, here's my swap chain, and I'm going to have a size t, current buffer index. And by default, it's going to be 0, and it's going to be set every time we present the frame, because the swap chain actually has a function which tells us which frame shall be used currently. You can see, after we present it, I can ask my swap chain. We can actually call get current back buffer index, and get current back buffer index is going to tell us the index of the buffer that's currently used for rendering. So if we do it as simple as that, this is always going to contain the right value, which we can then use on our, begin frame function as an index into our array sm current buffer index, so that we are always referencing the right buffer. Now, there's just one thing that we need to do. We need to implement the endFrame function. The endFrame function is actually doing exactly the same. We can copy paste the code. The only different thing is that, that's not what I wanted to do, is that now the state before is the render target and the state after is present. So here we have put it into render target mode from present, and now we are putting it from render target in the state present, so that after end frame, we can then display it using present. After, of course, all the work on the GPU has been done. Now, how do I use it in my main? It's not actually that hard. So somewhere down here, we have the to-do drawing. Actually, no, let's put it into begin drawing. So as you can see, we have init called init comment list. We've initialized ourselves the comment list. And now what we want to do is we want to use that comment list to start drawing a new frame on our window. Let's put it in here because I have reasons for that. So let's get the DX window. And let's call begin frame, and we're going to put in the comment list so that we can begin a frame on the comment list. Then let's maybe move it in here. Let's say draw to window, and then here it's going to be the to-do draw, and then down here we want to call the end frame function, and between of that we want to do the drawing. And currently we are just making sure that our resources are in the right state. If I now run that, we shouldn't really see a difference. Application still works. Can still resize it. I can minimize it. I've got to get an error. Okay, that's interesting. Let's investigate that error. A comment list which writes to a swap chain back buffer may only be executed when the back buffer is the back buffer that will be presented during the next call to present. Such a buffer is also referred to the current back buffer. Swap chain, unnamed object, current back buffer, unnamed object, attempting to write to buffer. Okay. So we have written to the wrong back buffer, actually. That's interesting. We could have an issue because present. Yeah. Because if we are doing resizing, the value is not updated. That's a problem. It's currently only updated if we are presenting. However, if we are resizing, it's not updated. So actually, we should defer that call out of present. And we should defer that call to our begin frame. So if we are on begin frame, we update the index and then it's going to be valid until we end our frame. So we should defer it into here so it's set it in the right state. Sorry. Now it should work. I should be able to move it around. I should not have an issue in my output. I can't really see it currently, but now it should be good. If I now scroll a bit up, we should not see issues in here. Yeah, you can see we don't have issues in here. Now everything is working. We are in the correct state. Now today I also want to show you that we have actually done work on the GPU, because we now have actually put commands on the comment list and we have abused the comment list for doing it, changing the resource states, and I actually want to show you that that works. So let me quickly compile this in release and start inside graphics, my quick debugger. Of course, I didn't start it in admin mode, which is bad. So let's do a new project here. Let's go to my build directory, release binary. Let's select it here and let's launch the frame debugger. Let's keep my Steam process and let's see. There we go. You can see that we get our overlay where we can see our FPS, hit 11 for frame capture, and that's exactly what we're going to do. We're going to hit F11 and now we can inspect what happens during the frame. You can see that we now actually have this frame debugger that's active. We have a kind of like play bar here, and we should be actually even able to drag the frame bar. Yeah, you can see we have two events on that frame bar, event 0 and event 17. Event 0 is probably going to be our resource barriers, and event 17 is also going to be our resource barrier. You cannot see something that's on the screen. You're not going to see anything here because we're not doing anything. If we would do rendering here, it would be black here, and on the right it would be fully drawn. However, to get a bit more insights, I'm actually going to go inside graphics to actually see what's happening. And what you now can see here on the left is a so-called event view. And in that event view, you can actually see what happened on the comment list, as well on the CPU as on the GPU side. Currently, you can see that the GPU has not done work at all because all these resource states were really just virtual and did not do something on NVIDIA, but we need them. And you can see how many time they have kind of like done on the CPU. So you can see basically start of the capture. You can see all of my CPU work. You can see that I called, let's maybe make this a bit bigger so that you can see what happened. By making that a bit bigger. Can I make that smaller? Yeah. You can see that first of all, I called reset on my comment allocator, and then reset on my comment list. Then I called get current back buffer index, which was 1. And then I closed my comment list. Right? This is basically what the CPU has saw. There. You can see we have resetted states, we have retrieved. No, I don't want to bookmark that. We have resetted states, and we have retrieved the current back buffer index. These were kind of like all work that hit the driver. And then we closed the comment list. This also hit the driver, and everything in between on the CPU side did not hit the driver. So actually our resource barriers that are somewhere down there, they actually never kind of like hit the driver because they were basically just done by the DirectX 12 API, kind of like enqueued using the allocator and the comment list. And then at some point when we called executed comment list, we basically began the event on the GPU. Now this basically published the comment list to the GPU, copied all the commands over and started the work. And now we would have seen some work on the GPU. However, execute comment list is not directly executing on the GPU. It's basically executing in the driver, and the driver is going to the GPU if it needs to. However, this is kind of like most of the time seen as work that has been done on the device on the GPU. Now, what you can see is that we have two calls here in the comment list, begin comment list and comment list. There we have some calls in here, resource barrier, another resource barrier, and that's exactly what we have done. So if I think, I should be able to see a bit more information about the event. Yeah, down there it is. You can see that we have one barrier, and you can see that we had a transition. And if I would open this up, you can see that we went from common to render target. So present, which I told you is common. You can see it's here just encoded as common, because of course it's the same value. Inside graphics is not going to be able to tell what we called. You can see that we called this on an ID3D12 resource, which is a texture 2D, exactly as I told you. And actually, if I do that, I can actually click on that, and you can see all of the objects. You can see that we have two textures. We have the device, we have the swap chain, and we have the fence that we use for synchronization. We don't really see the queue here, interestingly enough, but queues are, I think, actually somewhere else in inside graphics. So yeah, now you can see that it's actually now going a bit too deep, right? Let's close this up. Now you can see basically that we had a resource barrier from common to render target, and then we had the resource barrier from render target to common. So these are basically the two changes that we had here. Then you can see that the comment list was finished and begin of CPU workbench, whatever. Then you can see that we actually had a signal call to the GPU or the comment queue. So we basically told it executed comment list, and while that comment list was executing, kind of like in the background asynchronously, we also told it to signal. So as soon as your work is done from the comment list, signal it. Then I told that I should set this event on completion. Set event on completion, yeah, as I told you, basically previously means that it shall tell it as soon as the frame is finished, as soon as the work on the GPU. So all of that is finished. It shall set this event. You can see it really didn't take time because it's probably already done. And yeah, basically then we were finished, and then we continued on with our next call. The next call was the present call to the swap chain. You can see that this is currently taking the longest time. Well, because we are doing vsyncing, it probably needs to wait until the next vblank is there. Then it needs to swap the buffers, and then we're basically going to start over from the top here for the next like event, and boom, we can see what's going on. And yeah, if I go to present, now it's not showing me that. Yeah, there you can see now if I go to present, you can see we're going to get a bit of more details on the right. On the left, we're going to get a bit of details on the calls that we had on the API. On the right, you're going to see a bit of information. You can see the back buffers. You can see the index 0, for example, was not the current swap chain buffer. Index 1 was the current one, so you can actually see it. It's actually already here shown as well. You can see the buffer usage, buffer counts, and all of the details of the buffer that's on the right size of my 2K monitor, refresh rate that has not been set it up, the format of it, and all the details. You can see it in here and see what was kind of like going on here. And yeah, that's basically how that debugger, this frame event resulted. So you can see DirectX 12 is there's really many things to do to basically have a empty thing, and we're even gonna abuse it more, right? In the next video, we're gonna even do more commands that not do anything in terms of visually what we see. That's gonna go between these two resource barriers, of course. Then, so yeah, DirectX 12 again. Very complicated, but powerful. You need to do everything, including these optimization stuff like resource transitions. And you can even see, like, probably the driver might have completely discarded this resource barrier because it might not do optimization on it. But on some GPUs it might does. On some GPUs it might not does. NVIDIA might not do it, AMD might do it. Other way around could also be. Intel might be the only one that does optimizations there. I know. You never really can tell if these resource barriers would really be required. They are required because the API tells you to have them in here. Might it work without them? Maybe. Do we know it? No, we don't. The only thing we need to know is we need to always tell the GPU our right resource state. In this case, from common or present to render target. From render target to common. What it does in the background, we don't know. Might do something, might not do something, but we need it. All right, was a bit longer than I expected. I don't know how I initially intended to make it in one video with like the last video and this video. Now this is already a half an hour long. I know we are progressing slow currently, like 10 lines of code or something like that, an half an hour video, I know. But it is DirectX 12, it is a complicated API. Real-time rendering in general is really complicated. You're gonna write whole papers for a shader that's 10 lines long. That's basically how rendering works, how graphics programming works. And yeah. But I thank you for watching. We're gonna see us in the next video. Make sure to like and subscribe, and have a nice day. Bye.